about today circles. All right. You should have done 3.1 was the introduction. 3.2 was parabolas, and we talked about those last week. 3.3 are circles. Circles, I think, are the easiest conic sections because there's one formula, there's a center, HK, and there's a radius. And that's it. It doesn't get any more complicated than that. Those are the pieces and parts of a circle. And those are the pieces. There's just no other way to go about doing it. It's just not that hard. The one thing I do want to remind you, and I know, don't be offended that I'm reminding you of this. Yeah, it's pretty easy. The radius is the distance from the center to the outside of the circle. Sometimes it might have been a while since you've done stuff with circles, and you might have the radius and the diameter confused or just forgot. So the radius is the distance from the center to the outside of the circle. The diameter goes all the way across. So just to remind you of that. I know y'all know that. Don't be offended. I know you know that. Just it's a good thing to refresh your memory because I've always had students, every once in a while a student will get that backwards because it's been a while since you've done it. All right, so let's talk about this one. This is find the center and graph. So we're going to find the center of this circle and we're going to graph the circle. It's not that complicated. Give me a, can y'all see my little whiteboard screen here? I know that it's kind of on top of that one. Hold on a second, let's do it like this. Now can you see my little whiteboard screen? And I got to get the problem written down. It was x squared plus y squared, and then it had a 16y and a 4. Hold on a minute, what was it? Negative 4y minus 16. Minus 4y minus 16. This was a 4. Okay. Now I a y that I need to complete the square for because this one doesn't have an x term, it just has an x squared. So we can think about the x squared as being x minus 0 squared. Yay, that one's done. And then we've got y squared minus 4y, and then we've got our minus 16 here equals 0. So we're going to complete the square. We have to find our special number, and we're going to take our b term, we're going to half it, and we're going to square it. Oh, that's a square. It's just kind of a funky looking square. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. That's our lovely, special, wonderful number that we're going to add. But if we add 4 here, we're going to take away 4 here, right? Adding and taking away is like adding nothing. So we didn't change our equation. So now we can write this as y minus 2 squared. And this is x minus 0 squared. And then I'm going to put these two together. That's minus 20. So I'm going to move it to the other side by adding 20 to both sides. Okay. Now I'm in the format that I can tell something about this circle. All right, let me scooch that up a little bit. Can I do that? Okay. So the thing that you have to be careful about is we're going to write this as the square root of 20 squared. Because remember, the radius, the formula is x minus h squared plus y minus k squared equals r squared. So the radius has to have that square to it so that we'll know what it is. So our center is HK, or in this case 0, 2. I will let Earl in. I think Earl goes by Billy. Oh, my pencil is on the ground now. I can't reach it. There it goes. Okay. Hey Earl, good to see you. All right, I got you here. You might want to listen to the beginning of the recording. Oh, let me let Morgan in and I'll tell her the same thing. Hold on, look up. Hey Morgan, good to see you. Y'all might want to watch the beginning of the recording just so you can grab the announcements and the beginning of that first example that we're finishing up. All right, so our center is 0, 2, and our radius is the square root of 20. And that's about 4.5, just so you know. It's about 4.5. And that's a equals, but it just got kind of crazy looking. There we go. All right, so there's the two pieces of our circle. Boom, we're done. Circles are just not that exciting. There's just not that much to do. Oh, we do have to graph it. Y'all ready for the graph? It's exciting stuff. All right, so here's our grid. Let's graph this circle. Oh, that's not what I wanted to do. So we have a center of 0, 2, so we'll put our center right there. And then we'll go up 4.5, we'll go down 4.5, we'll go over 4.5, and we'll go over 4.5, and then well, I missed my marks, but that's okay. So I know that this ordered pair is 0 and 2 plus square root of 20. And this one is 0 and 2 minus the square root of 20, because I went down. And this one is the square root of 20. Oh, wait, it goes right here. Sorry. 2. And this one is negative square root of 22. And there's the ordered pairs. Not that I don't think that you have to give those ordered pairs, but that's just free for you. I won't charge you for it. Not there. So it's just up how much ever the radius is, to the right how much ever the radius is, down how much ever the radius is, and to the left how much ever the radius is, and then connect the dots. And there's your graph. Dun, da, da. And there's no focus, and there's no directrix, and there's no asymptotes, and there's no other pieces or parts. It's just the radius and the center, and it's just not that complicated. Yeah, we already found the radius. It's the square root of 20 right here. Right, remember our formula was x minus h squared plus y minus k squared equals r squared, right? And when we got this, we rewrote it as something squared. Yeah, that's okay. I kind of went through a little bit quick. I kind of go through circles a little bit quick, so it's just not that hard. You already know how to complete the square. You know what a radius is. There's not that much information to share. Once you get the center, you just count to get the radius. You know, you just go up, down, left, and right, and then connect the dots. Yep, no problem. No problem. All right, anybody else have questions about the circle problems? You have to know the formula, but it's not that hard. Yay. Okay, now you're ready to do ellipses, which is one of my fave. I love ellipses and hyperbolas. And when I get to show you how the two are connected, it makes me very happy. And I get a little bit ridiculously very kind of dorky and silly. I get excited. I know it's kind of silly and whatever. It just makes me happy. Okay. So let's move on to ellipses. And you have a whole lesson of circles to do. Please do those practice problems. There's just not that much to them. It's really just an effort in practicing completing the square, which you need that practice because you're going to do it over and over and over. Did you find that when you were doing those parabolas, you kept having to complete the square? You should have had a couple or multiple ones where you had to complete the square. Yeah. And so by the time we get done with the conic sections, now you're like, oh, now I know I have to complete the square. When you do quadratics, because you got to know how to do it. That's right. Okay. All right, so let's do ellipses. The key, write this big on the top of your paper, the key to what is important about ellipses is which denominator is bigger. That's important. And you don't even have a clue of why that's important, but I'm just telling you, if you'll write that down, put a star by it, circle it, make it with a red marker or whatever so that you remember the key thing to remember about graphing ellipses and dealing with ellipses is which denominator is bigger. You don't even know what that means yet, but I'm going to share it with you. So which denominator is bigger? And when we get to ellipses, hyperbolas is which denominator is first. That's how you're going to remember the two. They're different. They're different. So ellipses, which denominator is bigger? Here's some vocabulary that we're going to talk about. We're going to go over. Center is going to be your HK, like what you would expect. Your major axis tells you which way that ellipse opens. If it opens this way, your major axis is a vertical line. If it opens this way, your major axis is a horizontal line. Your minor axis is the other one. Focus points are always on the inside on the major axis, and we're going to go over this. Vertices are the endpoints, and co-vertices are the endpoints of the minor axis. All right, so lots of vocabulary. And here, oh man, what did I do? Now, how do I get those circles that I made off of there? Let's see, can I get that off? Now, these pictures, you do not have to rush and hurry and write it all down. I got them straight out of the textbook. So you have this picture. We're just going to refer to it very quickly. All right, so for that vocabulary word, when you're talking about an ellipse that's horizontal that goes this way, the major axis is this direction. It's longer than the minor axis, which goes this direction. These endpoints are the vertices because they're the endpoints of the major axis. These endpoints the focus points are always on the major axis, on the inside, right? They have a distance from the vertex to here is a distance, and from the vertex to here is a distance, and we'll talk about that in just a second. So, and the same things apply when it's a vertical ellipse, except the major axis goes this way, and this would be a vertex, and this would be the other vertex. The co-vertices are here and here, because this is the minor axis. So that's how everything's related. Any questions about either of these two pictures? And you don't have to draw, I mean, you can put it on your notes if you want to, but these are straight, I copied this and pasted it straight out of the textbook. So you have a copy of this in your textbook. All right, now, here are the formulas that are important to remember. All right, now, in the book, there's a bunch of formulas. These are the two that you have to remember. Now here, remember I said which denominator is bigger is the key, right? And I'm going to show you why. Let me change my color here. Let's do a purple. In a horizontal ellipse, the bigger denominator is under the x. It's under the x. In a vertical one, the bigger denominator is under the y. The major axis goes this way. The key is which denominator is bigger. You can't see the whiteboard. I'm not writing on the whiteboard. I'm drawing on the PowerPoint slide. I know that's unusual. Usually I write on the whiteboard, but right now I'm just kind of highlighting on the PowerPoint. No, it's okay. Yeah, you can hit full screen, but I'm not writing on that whiteboard, so that it's not even up. All right, the key is which denominator is bigger. So if the bigger denominator is under the y, then the ellipse goes up and down. It's longer that way. If the bigger denominator is under the x, then the ellipse goes this way. It is important to differentiate the two, and that's how you're going to do it. You're looking at the bigger denominator. All right. And then you have one more. This is the Pythagorean relationship, and it's important. Oh, that is not correct. This should be a minus here. I typed that wrong. This should not be a positive. This should be a minus. This should be a subtract. It's a squared minus b squared. Both of them are a squared minus b squared equals c squared. Why in the world did I do that? Holy schmoly. Not good, not good. Let's see if I can make that look different. Maybe I could. This should be a subtraction. So for the ellipse, the equation has a plus, but the Pythagorean identity has a minus, right? The equation has a plus, the Pythagorean identity has a minus. That's important because for hyperbolas, those are backwards. And I'm always going to try to help you understand why it's important to remember. So ellipses, it's a x minus h squared plus k, y minus k squared. But the Pythagorean identity is minus. And you don't even know what we're going to use that for yet, but just know that those signs are opposite. When we get to hyperbolas, it's the other way around. The formula is minus, and the Pythagorean relationship is a plus. I cannot believe I did that slide wrong. Oh my goodness, that makes my head very sad. Very sad. Okay, so let's do some problems with it. You think that might help? Okay, let's do some problems. Here's our problem. Write an equation of the ellipse. If the focus is 0, he's going to sketch a picture. I know there's not a bunch of people here, and this is an important lesson, so I hope a lot of them watch the recording. All right, let me show you real quick. Oh, there's Jameson. Let's let him in. Hold on, let's not save that. Let's pull this to the front. Let's look at that. Let's let Jameson in. Hey, Jameson. We just got started with ellipses. We went over the formulas and stuff, so you may want to watch that recording to get the beginning and the announcements and stuff. Okay, so let's do this problem. It gave us that the focus was 6, 0. Oh. And the vertices, the co-vertices are 0, 8. Hold on a second. 0, 8. The co-vertices were 0 plus or minus 8. Now, yeah, I do that too a lot. I'll be like, oh my goodness, it's 2 o'clock already. All right, so what I'm going to do, and I always do this, is I'm going to put what I know on my graph. And if I do that, it's going to help me get an idea of what I'm looking at. So my focus points are positive, negative, 6, 0. So we'll put that out here, right here. And we'll put negative 6 out here. And we know our co-vertices, and I'll make them blue, are 0, 8. Okay, we'll make 0, 8 here. And we'll make 0, negative 8 out here. That's our co-vertices. Now here's the thing to think about. The co-vertices are the minor axis. So this is going to be an ellipse that's longer this direction. Now the way I drew this graph, we may not get that. Let's see. Well, let me see if I can scooch these in a little bit so we can kind of get a better idea of what that looks like. Scooch that in just a smidge. Well, that's not what I meant to do. Hold on a second. Now, if you're using graph paper, it will help you not make an issue where it's not like since that's our co-vertices, we know our major axis goes longer the other direction. So I don't know exactly where this thing's going to be. It's going to be something like something longwise like this. Oops, I missed it, but that's okay. Something like that. Okay, I know my center is going to be right here because my focus points are always the same distance apart from each other. So I know my HK right away is 0, 0. Now I need to figure out what this distance from here to here is and this distance from here to here is. All right, so any questions about what? Now, this is a terrible sketch, but I get it. It's going to be a plus. Ellipses always have a plus. Y and K always go together. It's always going to be equals 1. And I'm going to have some denominator squared and some denominator squared. Which one's going to be bigger? The X or the Y? The X, because it has a major axis that goes this direction. All right, let's let Ambrose. Hey, Ambrose. All right, so I know my bigger denominator is going to be here. So this distance from here to the co-vertice is the B. So I know this is going to be the A. Now here's the thing you don't know because that picture didn't show you that. The distance from the center to the focus is C. Remember I showed you that identity, that Pythagorean relationship, and this one was A squared minus B squared equals C squared. The C is the distance from the center to the focus point. So we know that in this case. So we know the distance from the center to the focus is 6, so we have 6 squared. And we know that the b is 8 squared, so we got 8 squared minus, so now we just solve for a. So a squared minus 64 equals 36. Going to add 64 to both center to the vertex is 10 units. So this ordered pair would be 10, 0. And this other one over here would be negative 10, 0. So this ordered pair here would be 10 squared. Oh, that's okay. If you want to watch the beginning, Taylor, and then just let me know. I've got that you came for the last part, just because I want you to have that information. And then somebody else came in a little bit late, just a few minutes ago, too. Yeah, if you'll just watch the beginning and say, hey, Miss Long, I watched the first 20 minutes. I was here for the rest of it. That would be great. How did I get 8? They told me that the covertice ordered pair was 0, 8. So I know the distance from the center to the covertice, it gives me my smaller denominator. Ambrose, okay, cool. Yeah, just if you'll, I've got written down that y'all came, but you just came a little bit late. So just watch the beginning and then let me know. Taylor, where are you at? Oh, there you are. Oh, Tanner, that's it. No problem. Okay. All right, any other questions about how I did that? See, now we're done. It's finished. Okay, Brianna, that's fine. Just shoot me an email that you did it, that you watched the end. Well, it was easy, but if you got to get where everything is together and how it's all connected and related. Nope. Technically, I think the denominator this should be 100 and this should be 64. I think. Let's see. But the formula is squared. This is the answer to the equation of that. Now, did you have to sketch it? No, it didn't say you had to sketch it. But sketching it makes it easier. And they're not going to tell you sketch a graph and write the equation. The question says write the equation of the ellipse. That is finished. There it is. What I circled in red is the answer. Might be, might not be. It's not really a word problem, though. Look, this was the problem. Write an equation of the ellipse if the focus is this and the covertices are that. That's not really. Having the picture and understanding the bigger denominator is the major axis. The littler denominator is the minor axis. Yeah. Yeah, the picture is so much better than, now, if you like formulas, look in the book at all the formulas. You're welcome to use them. You do have to have this general formula, this one. Wait a minute, these two. You got to know those. But in the book, there's a whole bunch more for all the other parts and pieces. I don't like all those formulas. I get them backwards, and I forget them, except this is a minus. This is a minus. Don't mess that up. Okay. So let's look at our next example. Find the focus for this ellipse. Now, how do I know this is ellipse? I know it's ellipse right away because they're not the same, but the signs are the same. So I know it's an ellipse. So let's look at how to find the focus of this particular problem. I'm going to sketch a picture because that's what I think is easiest. But before I can sketch a picture, this doesn't look like anything in the regular normal format. So 36, 8, 288. Hold on, let me get that problem written down. Oh, that's not what I want. I'm understanding the picture. Okay. Make sure I didn't miss anybody's question. That's okay, Ambrose. It's okay. It's no problem. Okay. 8y squared equals 288. Okay. All right, you should be able to see the whiteboard now. All right, now this one says find the focus points. We're also going to find the vertices and the co-vertices, and we'll probably also go ahead and find the center, because once we have the picture, it's not that complicated. Now we know our general form of an ellipse is going to be x minus h squared plus y minus k squared always equals 1, and then it's going to be over a squared and b squared depending on which one's bigger as to what this graph looks like. Okay, let me just put and just divide everything by 288 so that it equals 1. All right, now my guess is 288 divided by 36 is 8. It is 8. Okay, so that gives me x squared over 8, and this one gives me y squared over 36, and this gives me 1. Dun, dun, dun. What's my center? What's the h and the k? A whole bunch of people are typing. Who types fastest? Let's see whose pops up first, or whose computer is fastest. Nobody's as fast. Y'all are typing fast, it's just not coming through. It will in a second. I'm going to be patient, because I know y'all know this. Somebody knows it. Why isn't it coming through? Am I frozen? Nope, I'm not frozen. We're trying to think about the center. Remember, the center is the h and the k. So it's think about the formula, though, right? That it's x minus h, right? Not the denominator. The denominator doesn't give you the center. It's whatever's being subtracted from the h and whatever's being subtracted from the y. There's nothing here. That's the key, right? It's like x minus 0 squared. Scooch the square over. Javante, you get a gold star for trying. And everybody's like, I think I know. Ooh, I don't know. And Javante's just went through. Yeah, and you're not the only one that was thinking it was the denominators. The denominators, remember, give you the length of the major axis or the length of the minor axis. And so that's something to keep in mind. Minus 0, and then that square is on the outside. So it was a little bit of a trick because there really isn't an HK. I mean, there is always an HK. But in this case, ooh, it's 0. Well, come here. Move back over there and just stay. Don't get bigger. There we go. All right, so our center is 0, 0. So what I'm going to do is I'm going to sketch what I know. I have my center right here of HK, 0, 0. Now, I know that this number has to be something squared. So 6 squared. So that gives me the number that I'm going to go up 6 and down 6, because that's below the y variable. So that's why I went up and down. This one, I have to write it as something squared. So it's a little tricky. It's the square root of 8 squared. So also have variables up there. And the square root of 8 is about 2.8. Okay, you have to write it as something squared. So because this number is below the x, I'm going to go over the square root of 8 this way, and I'm going to go over the square root of 8 this way. So look, there's my lovely little ellipse. Right? So I know it goes up and down. See, the bigger denominator is under the y. The y is going to be the major axis. So right now I could give you the vertices and the co-vertices. So the vertices are 0, 6 and 0, negative 6. And the co-vertices are the square root of 8, 0 and negative square root of 8, 0 are my co-vertices. All right, so this is a co-vertice. This is a the distance from the center is c. So when I think about it, I've got to find this distance here and this distance here. And that you always are going to use that Pythagorean relationship to find the distance or the focus points. So it's a squared minus b squared equals c squared. We don't know c. That's what we're looking for. And a is the bigger, so it's 36. A squared is 36. B squared is 8. So 36 minus 8 is 12? 28. 28. And then the square root of 28 is about, let's say, 5.3. Just so you know, is about 5.3. So what C is right here. It's going to be 0 square roots of 28. And this one's going to be 0 negative square roots of 28. Is this focus point. Because we went down the square root of 28, and this one we went up the square root of 28. So these are our focus points. There's always 2. Now do you see how having the picture helped me know is the square root of 28 the x part or the y part? Because it's on that major axis, I know that it has the same x value as the vertices. See, 0, 0, 0. So even if they don't ask for all the pieces and parts, once you get it in that format, it's easy to find them because if you sketch a picture, you just know where everything is. That was a lot. So anytime you're dealing with the focus points, you're using that Pythagorean identity. Okay? And for ellipses, it's always a squared minus b squared equals c squared. Anytime you're looking at or trying to find or work with the focus points, that's what you have to use. And that's why it's important to have the bigger denominator. All right, you know what? Y'all don't need this document right here because this was just for some graph paper for somebody else, so we'll just get that gone. Okay, I know y'all are writing, so I'm just letting you write. And then I'll type your questions. Or you can use your microphone if you have a microphone. I know you've got questions. And we're going to do another one. Because it's only 2:40, so we've got lots of time left. All right, give me a green check when you get done writing this down. Or write a question. Then I'll know, and I'll let you guys write, process, think about it. So when you're ready to move to the next example, give me a green check or type me a question. Because I know everybody writes at a different speed. And if we were sitting there and I was watching you, I would know when you were done, but since I don't, you just have to tell me. Why don't you tell me when you're ready to move on? And I want you to comment while you do that. because I'm starving. I did eat. Alright, so waiting on a couple people. Oh no, that's not good. I hate when that happens, Taylor. Alright, waiting on Austin and Camille and Billy and Nicole and Taylor. Taylor, are you ready to go to the next one? Give me a green check. Alright, cool. Oh, that's okay. And also I was thinking, wait a minute, Taylor's typing something to me, so she's good. Alright, good. Alright, Billy and Nicole, just wait. And don't hurry, write what you need to write. And if you have a question, please let me know. But well, that's kind of why I called out people's names, because then they're like, oh yeah, I've been done for 10 minutes. I'm like, oh, okay. I don't know when you type that in the Q&A pod, but alright. I'm going to wait just a minute, let Nicole and Billy get that written down. Everybody writes at a different speed, too. And my picture's kind of messy. Makes it a little bit hard to see. Alright, Billy, you done? Okay. Good, good, good. And just let Nicole finish up. That was perfect, because now I'm done eating the almonds. Alright. I think what our next example is going to be. Alright, Nicole. That's okay. Yes, I remember those days of having siblings that you're put in charge of. It's great fun. Great fun. Alright, Nicole, you about wrapped up? You ready for the next thing almost? And then sometimes you wonder if somebody's computers froze up or, you know, like, and then you don't want to hurry them because they're writing it down. Alright, there we go. Super. Alright, so everybody's good with that. Let's do another problem. Do I have another problem? Oh, I don't have another problem. Let me get another problem because there's definitely practice. You know, doing it over and over breeds familiarity and helps you to be able to oh, let's see here. Conic sections, ellipses, ellipses, ellipses. Let's do one where we have to complete the square. This one we didn't have to complete the square. And I guess I thought I would have a little more. Oh no, this one, oh that's right. These are all going to be centered around the origin. That's another lesson. Alright, let's do a different one. Let's do one where we have to write the equation with the given focus and a vertex. Let's do a vertex and a, oh no, that one's too easy. Let's do, let me find one I like. I don't like any of these. Hold on. Let me turn the page. Alright. Y'all are going to love these because they're really pretty straightforward. Let's do this one. And every time I've ever taught this before, you do all the ones centered in the origin and the translate. 0, 5, and that we have a y-intercept of 8. And they also tell us that the center is at the origin. And that's it. And they want us to write the equation of the line, or the equation of the ellipse. So I'm going to always sketch a graph so I can get an idea of what I'm looking at. I know my center is here. So this one's a focus, and this one's another focus point. So I know that this goes longwise this way because ellipses, the focus is always on the major axis, right? And I know I have a y. What are the vertices of this ellipse? Now this is a rough sketch. These are going to be rough sketches. It's just an idea of where everything is in relation to each other. That's where the focus points are. I have a focus here and here. That's a F for focus. The little kids eat the craziest things, I know. All right, as an ordered pair, though, Taylor, think about it. There you go. Exactly. 0, 8, and 0, negative 8. Okay. Now, I know that the distance from the center to the focus is C, right? I know the distance. Need to know. Okay. So in order to find the B value, we're going to use the Pythagorean identity. So C squared equals A squared minus B squared. And that's what it is for 5 squared minus B squared. So we subtract 64 to both sides, and that gives us 39.1. Value is going to be the square root of 39. And whatever that is. I don't know what the square root of 39 is, but I have a calculator, and it tells me that it's about 6.2, which is, I'll do a squiggly equals 6.2. And negative square root of 39, 0 out here. And that's important because that gives me that's correct. Okay, so my co-vertices are square yet, but I need to. And I'm going to, because now I have all the pieces and parts that I needed. And I'm trying not to do it too quick so y'all can think about what you have questions about. I haven't done it yet. That's right. I'm just gathering up the information that I need. Now I know what I need. I needed the length of A. Whoops, what was that? I don't know what I was doing there. I'm just trying to move that out of the way a little bit. All right, so we know that it goes up and down, which means which one's going to have the bigger denominator, the x or the y? And it always equals 1. Right. Well, think about it. The major axis is this way. Right? Since this is longer, it has the bigger. This is the y-axis. The y is going to have the bigger denominator. And it's all about visual, seeing how it all connects together. That's right. Does that make sense? Since it goes up and down this way, this is the major axis, then I know the y is going to get the bigger denominator. B is 6.2. And over here, I'm going to have 8 squared. And it equals 1. Let me see if I can scoot everything up a little bit. That's the hardest part, is getting that denominator correct. All right, so this is a square, and this was a square. So we end up with x minus h squared over 39 plus y minus k, or actually we would want to put 0. X minus 0 squared. And you could leave off the 0, but I think it's just good habit. So when you start having a center other than 0, 0, you're more familiar with that formula. Okay? And okay, all of the ones from this lesson will be centered at 0, 0. When we start translating them off of 0, 0, that's going to be a lesson that'll be next week. I believe it's 2:52 already. It is amazing how fast an hour goes. All right. Questions about this? I went through it pretty quickly. It does go by. I know. Can you believe? It's amazing how fast it goes. So and it doesn't matter which way the ellipse goes. That's the case. A is longer in ellipses. That's the key. A is longer. The longer denominator you go. If you wait till the end and you try to sort it all out the day before you take that unit test, it's going to be a mess. Do it day by day, practice by, lesson by lesson. Ball wax. I don't know why. Whatever. All right, real quick before we go, let me have hyperbolas, because if you don't, it's very similar, but what we're going to do with the information is a little bit different, and it gets me like very, very excited. But if you don't have ellipses down, get that practice of parabolas, and you get your practice for your circles so that you have all that information straight, because when I throw in the info about hyperbolas, you need to already know what you know about the other conic sections. Only if you're listening to the recording. I do not need anything else from you except that you were here. And that's one of the benefits of coming live. One is you get to ask questions, and you get to make sure you get clarity when we're going over stuff. And two is you don't have to do any follow-up work. Except for those couple of y'all that came in a little bit late. If you'll watch that beginning and just notes. So even if I asked you to send it to me, it wouldn't be a big deal because y'all were taking notes. Y'all were paying attention, right? So it's not a big deal. Right. That's right. Absolutely. All right, so y'all practice. Have a great rest of your afternoon, and I will see you next week in live lesson, and hopefully that'll be good. All right, see ya. Bye. Billy, if you'll just watch the beginning so you can get those announcements, and that's fine. I've got you. In the morning. Sarah, if you'll email me what you need help on, I'll either send you a link, I'll give you a written explanation, or I'll give you a call. But I'm in live lesson till 4 today, so it won't be today. Okay, yeah, just webmail me what you need help with, and I'll get you an answer. And it's probably not going to be first thing in the morning because I have staff meetings on Wednesday mornings, and then I have more live lesson Wednesday afternoon. But I'll get in touch with you. I'll either send you a webmail, and we'll schedule a time together, or I'll give you a phone call. Okay, so just shoot me a webmail about what you need help with.